All right, folks, we have talked about triangles, we have talked about polygons, we talked about quadrilaterals. We are now ready to move into area. So, area starts a big part of our year that is going to lead us into surface area and then volume. And honestly, from here on out, everything pretty much involves a formula. And knowing what formula to use when and plugging the numbers in and generating an answer. So it's all pretty straightforward from here. So the area of a rectangle or parallelogram or rhombus or square can all be found using the same method. Okay, area is base times height. Now for a rectangle, it's pretty obvious why that is. And I tried to make these papers dark enough so that you could see the squares that I was drawing on. So you can see that this is 8 wide and it's 4 tall. And that creates these 8 different columns and these 4 different rows for a total. If you were to count up all of these squares, you would count them all up and you would get 32. Okay. Well, that works on this one, on a rectangle. It also works on a parallelogram. The base and the height can be found because there's always going to be a right angle wherever the base and the height are. Since this is a rectangle, that would be where my right angle is, so this is my base and that's my height. On this one, this is not the height. The height is always, like I said, at a right angle. This would be the height. The base and the height are where those two things meet. So you count the base, how wide the base is, it's an actual line, and the height could be an actual line or it could be a dotted line. So if we count this, we get 1, 2, 3, 4, 5, 6, 7, 8, and this has a height of 1, 2, 3, 4, and 8 times 4 is 32. So these two things have the same area. But if you look at them, you're like, no, they're not the same. They don't have the same. They shouldn't have the same area, but they should, because if you can imagine cutting this piece off and transporting this piece, this part of the rectangle or this part of the parallelogram over here, it would make the exact same rectangle that we have right here. This rectangle and this rectangle are the exact same size. All I did was cut this section off and move it over. Okay, base times height works on parallelograms, rectangles, rhombi, and squares. So in our first example here, a parallelogram has a base of 15 and a height of 7. What is the area? You could draw a picture, but if you have all the information you need and you know the formula, all you got to do is plug the stuff in. We know the base is 15 and the height is 7. What is the area? Well, that's what we're figuring out. And 15 times 7 is 105. However, it should actually be 105 square inches. Okay, because this is 15 inches and 7 inches. 15 times 7 is 105. Inches times inches is square inches. Inches squared. All right, coming down here to this one, a rhombus has a base of 8 and an area of 60. What is the height? Okay, well, we could draw a picture, but again, if you look at the formula and see if you have the stuff you need, we know the area is 60 and the base is 8, and it's asking what the height is. We can totally solve that. Okay, we don't need a picture for this one. Plus, a picture of a rhombus and the area is going to be kind of tricky to draw. You don't really know what the height is, so it's hard to draw a rhombus like that. So to solve this algebraically, all you do is you divide both sides by 8. And this side would just be h, the height, and this side would be 7.5. Have to think about that for a second. That's 7.5. 8, there's 60 divided by 8 is 7.5. All right. This one says a square has a perimeter of 24. What's the area? Well, perimeter we haven't talked about. I apologize. Perimeter is the distance around an object. Okay. So if it has a perimeter of 24, Well, let's see. This square would only have a perimeter of 4. 1, 2, 3, 4. This square would have a perimeter of 1, 2, 3, 4, 5, 6, 7, 8. This square has a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're getting there. Let's try a slightly bigger one now. Let's try this one. This one has a perimeter of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're getting close. Maybe one more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There we go. So the perimeter is 24. Now, the easier way to do all of that would have been just to say, okay, Jim, okay, so we got all of it's 24. This plus this plus this plus this makes 24. So how long should one side be? Well, 24 divided by 4 is 6. Okay, so that would have been an easier way to figure out, oh, it's going to be 6 by 6. And then 6 up and 6 over. So this is 6, and this is 6, and this is 6, and this is 6. Now this is a square. To find the area, it's just base times height. Well, the base and the height are wherever the right angles meet. 6 times 6. The area is going to be 36. And again, if we don't know what it is, it really should be units squared. But if I don't label it in there, I'm not going to label it on there. If I don't label it in the problem, I'm not going to label it on the answer. So the last type we have is a composite picture like this. Okay, so what to do on a composite? There's a couple schools of thought. All right, most people like to break it down into 2 parts or 3 parts if they need to. Some people like to find the area of the entire thing and then subtract the part that's not. So we would find the area of this entire rectangle, I'm assuming, and then subtract this rectangle, and then whatever's left is the area we need. I'm going to break it into 2 parts because while that's a good practice and it does work, it's a little trickier on ones like this that we would break into 3 parts to subtract those other pieces. So I'm just going to break it into pieces for us. So we're going to have this rectangle and that rectangle. We're going to find the area of that rectangle, find the area of that rectangle, and add them together. That's the area. Perimeter, we still have to add all the sides up. So what sides do we know? We know this one's 4. We know this is 2. We don't know this. Well, I know this is 7, and that's 4 as well. Well, I know that if this is 4, and this part right here is 2, that's like saying this is 2. 4 and 2 make 6. That means this side over here has to be 6. And if this whole side is 7, but this much is 4, that means this much has to be 3. Because 3 and 4 make 7, so this has to be 3. So now I think I have all my sides. Let's see, I have 1, 2, 3, 4, 5, 6 sides, and I have 1, 2, 3, 4, 5, 6 numbers. So if I add all these up, 6 plus 4 plus 2 plus 3 plus 4 plus 7 is 30? Really? Yeah, that's 30. That's the perimeter. For the area, however, I need to know the base and the height of this and the base and the height of this. Okay, the base of this is not 7. It's just this rectangle. So that would be this side and this side. That's where our right angle is. All right, so this side is 3 and this side is 4. The area of this is 12. All right, and then the area of this one, again, this is not 7. Okay, the base and the height, there were these 2 things, the right angle is, and this base right here is 4. This is only 4 wide. And this is 6 tall, not 2 tall. And 4 times 6 is going to be 24. And we add 24 and 12 together. And that's going to give us 36. 36 square units, but 36 is just fine. It's not labeled, like I said. Really should call it square units, but I usually do not. Okay, on this next one, we got some missing pieces as well. Count the sides, and let's figure out how many pieces we're missing. I'm counting 8 sides, but only 6 numbers. So I'm missing 2 sides. Okay, one of them's really obvious, the other one takes a second. Okay, the really obvious one is this one. Okay, and what you can do to figure out how long this one is look at these numbers that are going sideways like this. The 4, the 3, and the 2. So the whole thing, this part's 4, this part's 3, this part's 2. If you add those up, this part is 9. We need that for the perimeter. That's the only reason we need that one. We don't necessarily need it to find the area, but we do need it for the perimeter. All right, the other number that we're missing is this one right here. I know we want to say it's 2 because look, it's 1, 2 boxes, man. Well, this says 3. There's no way that's 3 boxes. So I'm not sure what that is. So let's look at this. It may be 2, it may not be. Let's look. So this is 5. So I go up 5, and then I go down some, and then I go up 5 more. But that whole journey on this side is only 8. So I start off, I go up 5, it's positive 5, then I go down a certain amount, then I go up 5 more, but all in all, I only moved 8 spaces. So 5 minus something plus another 5 equals 8. Okay, it may take a second. You can do the algebra. You can think about it. Let's see. You can also say, okay, if I'm at 8 and I go down 5, how much do I have to go up to be able to go down 5 more? Okay. If I'm at 8 and then I go down 5, I'm at 3. I'm at 3. I got to go up 2 more to be able to go down 5 again. So this has to be 2. Algebraically, you would get 10 minus x equals 8, and then hopefully you know you could switch those. And you get that that's 2. So we add all these up, 9 plus 8 plus 2 plus 5 plus 3 plus 2 plus 4 plus 5. All of that together, let's see, that's 17, 18, 19, 24, 25, 26, 27, 28, 29, 38, I believe. Let me see. 9 and 9 make 18. That would be 28, because that's another 10, and that'd be another 10, so that's 38. Yep, it is 38. Now for the area. I'm going to break it into these 3 sections here. This and this. Now sometimes when you do this, you actually have to find how tall something else is. So let's take a look at this. So, maybe not though. This is my right angle right there. I've got a right angle right there, and I've got a right angle right there. This is 2 wide and 8 tall, so that's 16. This is 4 wide and 5 tall, so that's 20. And this is 3 wide, but how tall? Well, this you can look just at this part. If this whole thing is 5, but this comes down 2, then that part is 3. Okay? So this is 3 times 3, so that's going to be 9. And 16 plus 9 plus 20 is going to be 45. Square units on that. 45. Somebody usually asks at this point, is the area always going to be more than perimeter? No. Most of the time, yes, but all the time, no. If you're dealing with smaller numbers, like 1s and 2s, it is very possible that the perimeter is going to be bigger than the area. But most of the time, you're not dealing with smaller numbers like that. So yeah, the perimeter, the number in the perimeter is going to be bigger than the number in the, excuse me, the number in the area is going to be bigger than the number in the perimeter. But that is not always the case. All right. Thank y'all.